on Wednesday's video. In this one, we're going to look at factoring a bit further. The method we are learning today is called inspection, and this is what we're going to do when we're factoring trinomials, where there's no GCF for me to take out. So let's hop right in. So here we are on page 335, and we're going to look at factoring some trinomials. So this is a little bit harder, a way for me to factor something out or undo the multiplication when I'm dealing with a trinomial. So the first thing we're going to look at is using tiles. The reason we're going to do that, well, when we learned how to multiply, the first thing we looked at was tiles. So as we look to undo multiplication, we could look at the tiles as well. So we'll walk through this and then I'll explain how we can actually step this up and do it without tiles. So there's some tiles, write the polynomial expression represented. Well, I see an x squared. And then I see 1, 2, 3, 4, 5, 6 x's, so plus 6x. And then I see 1, 2, 3, 4, 5, 6, 7, 8, plus 8. So there is my polynomial, x squared plus 6x plus 8. And if I'm going to factor this, what I'm saying is how can I write this as a multiplication? Okay, how can I write this as something times something where I get an answer of x squared plus 6x plus 8? Well, what we're going to do actually is go back to those area models and say, well, if this is my answer, what would I have been multiplying, okay, to get that product in the middle? So I have that grid just like we did when we multiplied polynomials. Now I already have the answer, and I want to go back the other way. Well, this is something we did last, kind of the first half of the unit. I understand that this, the thing I'm trying to factor, is the answer, and I want to know what the product are. What are the two things? Well, on the top, I have an x, a length of x, and 2. So I could fill that in. There's your x, and there's your 2. We could call that the length. And then down the side, I would say I fill in a length of x, and then I have 1, 2, 3, 4. So x plus 4. So what I'm saying is your dimension of x plus 2 and x plus 4 multiplies to my answer, which was x squared plus 6x plus 8. I just arranged it nicely in this rectangle. So it says write the area. Area equals x plus 2 times x plus 4. And that is the factored version of the polynomial we're looking at, x plus 2 and x plus 4. It says expand it out. Okay, well, we could do that. Repeated distribution. I distribute the x, and I get x squared plus 4x. Now I distribute the 2. You get 2x plus 8 plus 2x plus 8. Combine my like terms. That area is x squared plus 6x plus 8. Well, yeah, it had to be, because that's what I started with. Here's my answer. Here's what I started with. While we get into this factoring, and as we get into bigger and bigger things, what I want you to remember is I'm just trying to write it as a multiplication. So if I think I have the answer, I could multiply it out and get what I originally started with. Okay, so factoring, one method, and we're probably not going to use this a lot, is to draw it as a rectangle. Push all of your pieces together so that you could represent it with an area model. And then I can talk about, well, what's the length, what's the width? Okay, so we'll do one more question like this, and then I'll show you a legit method. Okay, so it says, write the polynomial expression which is represented by these algebra tiles. I have an x squared plus 1, 2, 3, 4, 5 x's, and plus 4. 1, 2, 3, 4 constants. Okay, if I want to write that as a product, a method with tiles is to say, well, hey, if I could kind of arrange that into a perfect rectangle, I could talk about its length and its width, or I could talk about what two things multiply to that area. So it's a lot easier when you have the actual tiles. Okay, and that's what I have here is the actual tiles. And I say, well, I got my 5 x's, I got my 4 1s. Well, I can kind of sandwich, and the whole time, if I add something, I'm trying to make it a rectangle. So okay, I kind of have to fill in that gap. And then if I were to bring in another piece on the side here, I'm missing a spot. So I'm kind of just playing around. My whole goal here is to write it as a rectangle, or organize it as a rectangle. Maybe I add that one. Okay, well now I'm missing a piece again, so I'll bring in a 1. Oh, perfect. I think I can actually organize this as a rectangle. So factoring with tiles is probably not the best method. And it's also a lot easier if you actually have the tiles in front of you. But it's the idea that these tiles represent an area, and I know a product that gives me area is the length times the width. So here is my rectangle. It's all the same tiles, I just organized it nicely. Let's do that over here. It says arrange them in a rectangle. Well, I had my x squared. And then I had an x going down. And an x on the side. And I had to fill in the 1. And then again, I had an x and a 1. And I think I had that 2 more times. Okay. And there you go. Okay, and then we can kind of break that apart and we can say, well, what did you actually multiply there? What was the product? And on top, if I fill in the gap, it looks like I'd have an x plus 4. The dimensions around x plus 4. And going down the side, I'd have x plus 1. So the factored form, I would say x squared plus 5x plus 4, that is equal to the product of x plus 4 and x plus 1. The length times the width. It represents the same amount of area, but instead of writing it as the polynomial, okay, I read it as the product that could be expanded to that polynomial. So that's the whole idea here. And the whole idea we look at areas, well, area is a certain thing where I kind of know a product that goes with it. Area is length times width when I put it into a rectangle. What we're going to move to is, well, can I do it without the tiles? And can I think, well, what would have multiplied to get me this answer? So that's what we're going to do. Okay, so let's go. We're going to skip class example number 2, and we're going to jump to the bottom of the page on the next page. And this is where we will pick up and go from there. And we're now going to take a look at how can I factor without the tiles. And this is how we're going to factor 99% of the time. We really only look at the tiles to kind of explore the idea and introduce the idea, but now this is how we're going to factor. So we're going to try to do it without. So to understand factoring, we first need to understand multiplication, right? We need to look at multiplication and say, how could I go back to that? When I look at my answer here, right, where did the x squared come from? Where did the 6x come from? Where did the 8 come from? From my original piece, right? I'll do the next one, x plus 3 and x plus 3. Well, that would be x squared plus 3x plus another 3x plus 9. So your answer of x squared plus 6x plus 9. So the question is, where did that 6x come from? Where did that 9 come from? Okay, I'll do one more. X squared plus your 7x plus your 1x plus 7 simplifies to x squared plus 8x plus 7. So the question is, from this original, can I see how could I potentially get 8x in the middle and how could I get a constant of 7? I'm kind of noticing, hey, you're getting those x squareds over and over and over. So you got 3 left. I want you to complete those 3, and then I want you to think about where do those values come from, okay? Where do those values come from? So pause.
A few moments later.
All right, and we are back, and I have completed all the multiplications. And I hope you have too, so you can check to make sure you got the right ones. And I hope you're considering where do these pieces come from. And then what we're going to look at is if I had kind of a binomial times a binomial. And the one key thing is it's just x and x. It's not 3x plus or 2x or whatever. It's just an x. When I multiply it out, where does the middle term come from and where does the constant come from? Okay, so I think it's easier, okay, to actually look at the constant first, the value of c. When it comes to p and q, so plus this or minus this or plus this or minus this, in all of those examples, you're wondering, okay, well, how did I go from a 2 and a 4 to a constant of 8? A 3 and a 3 to a constant of 9. A 1 and a 7 to a constant of 7. 5 and a 2 to a constant of 10. 5 and -5 and -2, constant of 10. 8 and -6 to a constant of -48. And you wonder, how could I take those two numbers and get my back constant or my C value? And what I hope you're seeing is you multiply them. It's P times Q. 8 times -6, -48. -5 times -2, positive 10. 5 times 2, positive 10. So that constant, that value at the end, is linked to the multiplication of kind of my two terms, my two pieces in the factor. Then what about the B term? Well, if I do the same thing and I go through, how do you go from 2 and 4 to 6, 3 and 3 to 6, 1 and 7 to 8, 5 and 2 gets me 7, -5 and -2 somehow got me -7, and 8 and -6 got me 2. Well, I am adding those. Okay, those original binomials, I multiply the values to get my constant at the end, and I'm actually adding them together to get the coefficient on the x term. And this is huge. If we can recognize these patterns and recognize these ideas, this is huge because it's going to allow me to go back the other way. It's going to allow me to factor the other way. Okay, let's explore this just a little bit further. Next example, it says use FOIL to kind of show how we can write this. Well, FOIL would be multiply the x and the x squared, or sorry, x and x get x squared, multiply the x and q, p and x I multiply, and p and q. So I'm saying if I factor that, multiply that out, x squared plus qx plus px plus the product of pq. Well, there it is. There's my constant, is multiply those two n terms. And then the middle one, p plus qx, yeah, those are like terms. So q and p I could combine together. If it was 5 and 7, it'd be 12x's. Whatever it is, I add those together. So if I can recognize this, I'm going to be able to factor. Okay? And here is what it's called. It says factoring x squared plus bx plus c by inspection. So something really important. This is just 1x squared. It's not 2 or 3 or 4x squared. It's just x squared. I can factor these. We call it inspection. And what that is we recognize that those products must have been, okay, two numbers that multiplied to equal c, so product equal to c, and two numbers that added to equal b, the middle term. These are from the multiplication. These are from the addition. So if I wanted to look at an example, this is the question I would ask myself. X squared plus 8x plus 12. If I wanted to factor that thing, if I wanted to write that as a product, I would find two numbers that multiply to 12, multiply to the constant, and add to 8. And what I would say is that thing equals, okay, well, what are those numbers? If I could find those numbers, I could fill them in because I know they go in the back end of the binomials. And those numbers, multiply to 12, add to 8. I think those numbers are 6 and 2 because 6 times 2 equals 12 and 6 plus 2 equals 8. We'll talk more about finding these in a sec. So I could plug in plus 6 and plus 2. Hey, I've successfully factored that polynomial. I know this thing, if I multiply it out, I get what I originally started with. Okay, down below, x squared minus 13x plus 12. Well, that one you're asking, well, still multiply to 12, but this time I need to add to negative 13. So I could say that is equal to x plus or minus something, x plus or minus something. And I know those things, whatever they were on the end, have to add to 12, multiply to 12 and add to negative 13. Those numbers would be negative 12 and negative 1. X minus 12 and x minus 1. So that is factoring. And we're going to go into more detail, so don't worry. But that is, in essence, what factoring is going to be. So to practice that, this is where question 4 comes into play. I need to be able to figure this out. I need to be able to find these two numbers. I call them the magic combo. I need to be able to find my magic combo. So let's practice doing that. It says find two numbers that sum to 12 and multiply. Their product is 20. So those numbers are 2 and 10. Absolutely. The next one, I need numbers that sum to 9. So they add up to 9 and they multiply to 20. I think those would be 4 and 5. And you could say 5 and 4. The order doesn't really matter. Okay. The rest of that chart, I want you to try ahead of me. And there's some hints at the bottom. So if you maybe want to read those beforehand, but then try this chart ahead of me, and this is where I'd invite you to pause the video.
346 minutes later.
And we are back, and I've completed most of the table, but I'll finish up a couple with you. So maybe before I do that, I'll read the comment. It says, if a product is positive, then the two integers, or the two numbers I'm looking for, must be both positive or both negative. It just meaning that they're both the same sign. Okay. If the product is negative, then I'd have one positive and one negative. So that's really convenient, right? It'll allow me to kind of right off the bat figure out what my signs are going to be. Okay. For the remainder of class, we're only going to look at examples where the product is positive. Next lesson, we'll add some more complicated ones. So add to 2, product of negative 15. Because it's a negative product, I know one of them is going to be negative and one of them isn't. Okay. And then I think, well, multiplying to 15 could be 1 and 15. I don't really know how that adds up to 2. And I think 3 and 5. Well, yeah, 3 times 5 is 15. And if it was maybe a negative 3 and a positive 5, you add those together, you get 2. Absolutely. Okay. Let's think. Next one. Product is 48. Sum is negative 26. Well, the product's positive, so I know they're either both positive or both negative. But because I'm adding up to a negative number, the only way I get to a negative number is if I have some negatives. So I'm going to fill in, they're both going to be negative. I know that already. And then all I have to think is, well, what multiplies to 48? 1 and 48, no. 2 and 24. Oh yeah, if it was negative 2 and negative 24, that adds up to negative 26. Multiplies to 48, I'm good to go. So finding this magic combo is going to be crucial, okay? Because we go, okay, if I am going to multiply factor trinomials, first I look for the common factor. No, there isn't one. The next step is to find your magic combo. Multiply to something and add to something. I multiply to the constant. So in this case, I multiply to 12, and I'm going to add to that middle term, the x term, so 8. And if I can find numbers that multiply to 12, add to 8, I can factor this thing. So I think those numbers, we already did this one, would be 6 and 2. Or if you said 2 and 6, that's totally fine. The factored version, what you're saying is equal. The equal sign is crucial. Okay. I'm saying the first term was just an x and an x. And then all I needed to figure out were what were those back terms in each binomial. It's a positive 6, so plus 6, and a positive 2, so plus 2. Done. The idea of factoring is, can I write this as a multiplication? And I absolutely can. Okay. There it is. X plus 6, x plus 2. Those two things multiply to my original piece. If I took this and multiplied it out, I get the original. And I'll do that. The best part about factoring, okay, I'm supposed to get x squared plus 8x plus 12. 8x plus 12. And what we said is we think that's equal to x plus 6 times x plus 2. Well, the best part about factoring, and you don't have to do this. I could ask you to do it, but you don't have to do it. You maybe do it on the side, do it in some blank paper, is you use the distributive property and you can check your answer. I get x squared plus 2x plus 6x plus 12. And I combine my term in the middle, and absolutely I get x squared plus 8x plus 12. So I'm writing. All I'm doing is writing the same thing in a different way. In this case, I want to write it back as multiplication. Okay, factoring is all about writing it in a more convenient way. That's all we're doing. Okay, Here's example number 2. It says multiply to 12, add to 13. Multiply to that constant at the end, add to the middle term, the x term. Those numbers would be 12 and 1, or you could say 1 and 12, doesn't matter. So the factored version, x plus 12 and x plus 1. That product multiplies out. I'm writing the same polynomial in a different way, in a more convenient way. And if I wanted to, check. Okay, multiply that out, check that you get the same thing. Okay, C, D, E, and F, you are going to try ahead of me, and then I'll wrap them up to finish up the video. I think there's only one question after this. So pause and go ahead of me.
6 months later.
And here's where I'm going to jump back in. I've done C and D, so you can check my answers on those ones. And I bet you're looking at E, right? And you're probably stumped. Maybe you went on to F. If I look at E, okay, multiply to 4 and add to 3. Multiply to positive 4, add to 3. If I am trying to figure that out, well, what multiplies to 4? 1 and 4. No, that adds to 5. Well, maybe it's negative. Negative 1 and negative 4. No, that adds to negative 5. 2 and 2. Well, no, 2 and 2 adds to 4. Well, maybe it's negative 2 and negative 2. No, same thing. Well, I've tried all the possibilities. Okay. And this is a rare instance. Okay. This is a rare instance. Okay. Where there's no possible result. So this thing is not factorable, which is a legitimate possibility. Sometimes I will give you things that are not factorable. Not often. Okay, I'm not often going to do that. But technically, if you exhaust all the possibilities and you've tried everything and nothing adds to the desired number and also multiplies the desired number, it might just be non-factorable. Okay, so that's one answer that you can get. So if I give you a question, there's nothing, you say, oh, yeah, I can't factor it. Okay, let's do the last one. Multiply to 50, add to 27. Those numbers are 25 and 2. So my factors, this is the product of x plus 25 times x plus 2. That product multiplies out to my original polynomial. Okay, that is factoring by inspection. That's really all there is to it. And this is something we're going to do over and over and over and over until we're really, really, really good at it. And it's almost second nature to us. Okay. Last question. Okay. Factor the following polynomial expression by first removing a common factor. Yeah, this is something, and there's a comment down at the bottom. There were 2 steps in this one. As we learn more and more types of factoring, I'm always going to say factor it completely. Factor it all the way. Factor out as much as you possibly can. So the first type of factoring I would look at is factoring out the common factor, which in this case is 4. Factor out the GCF. And I get left with x squared minus 8x plus 12. Well, there you go. So I factor out the common factor, and now I can factor just this piece in the brackets. X squared minus 8x plus 12, because you'd say, okay, multiply to 12, add to negative 8. And you find that magic combo, and you go from there. Okay, multiply to 12, add to negative 8, that would be negative 6 and negative 2. Those numbers multiply to 12, and they also add to negative 8, so that's my magic combo. So I have the factor of 4. Then I'd have x minus 6, and then I'd have x minus 2. That is the fully factored version. I can factor out a common factor, and then I know that I can also factor by inspection, and then I go further and further and further, and the more types I learn, the more things I look for. But the first thing you should always look for is the common factor. Okay, do be ahead of me. Okay, last question before I tell you the homework, so pause it very quickly, and then I'll reveal the answer and show you the homework.
A little longer than a few minutes later.
And there is your answer for B. Factored out the 3x, and then I factored by inspection to factor the trinomial left inside. And that is it. So just a reminder, always, 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 if there's a common factor, I remove that first. And here is your homework, page 340, 4, 5, 6, 10, but just A and D for 10. There you go. And that is it for today. So make sure to try that homework, send some questions in the Google form, set up a one-on-one meet, all of that stuff, and we should be ready to roll. So as always, thanks for watching. Smash the like button, and I will see everybody tomorrow.